Okay, ions, same element, different charge. I removed all this stuff from this test, but it'll be on future tests. Okay. Now, when we say charges, not credit cards, we're talking about electrical charges, which you should remember from batteries. You have your positive. And your negative. Now there's some vocabulary words that go along with that. Positive in your neutron, not your neutron, in your nucleus. Your positive particles are protons. Their symbol is little p with a plus. Negative is your electrons. And those are E with a minus. Okay. And your positive particles are called anions, all one word, and cations. So there's our vocabulary words that go with this. This is what leads into what an ion actually is. Now, in normal atoms, like if I write H2 or C or helium, these exist in nature as neutral atoms. So neutral have an overall zero charge. Neutral is zero charge, which means the number of positives equals the number of negatives, so they cancel out. For every positive particle, we have a negative particle, until overall it's zero. Now, hydrogen has one proton and one electron. But this time we have H2, so we have two hydrogens. So call it two positives and then two negatives. This cancels out this, and this cancels out this. Overall, 0. Carbon, 6 protons, 6 electrons. Again, they all cancel. Overall, the charge is 0, or neutral. Helium, same thing, but now we have 4 and 4. Cancel out, cancel out, cancel out, cancel out. Overall charge of 0. Okay, since we can never ever change number of protons, an ion has to have a different number of electrons, which have our negative charge. So even if it's something with a positive charge, it doesn't have extra protons, it has -1 electron. So let's look at one. Let's use hydrogen again. Hydrogen, and we'll say minus. The overall charge is minus, so normally there's one positive and one negative. But since we have an extra negative charge, we need one more electron. So we end up with 1 proton and 2 electrons. We're going to do lots of practice. Let's pick another one. Let's do... what's a smaller one? Beryllium. Let's say beryllium has formed a positive 2 ion. Beryllium normally has 4 positives, 4 negatives, but we have a charge of +2. Since we can't change the number of protons, we can't just say it has 2 extra protons, because then it's not beryllium anymore, it becomes carbon. So get rid of those. So we need 2 fewer electrons. So in this case, we have 4 protons, 2 electrons, so these 2 cancel, and what are we left with? 1, 2, which is what we're looking for. So we still have 4 protons, and only 2 electrons. Here are 3 sample problems. Try these on your own. I'm going to leave the video up for a few seconds so you can pause it and try to work it out. Or just wait a few seconds and then I'll just solve them for you. Alright, So then we have lithium plus. Lithium normally has 3 protons, 3 electrons. But we have an overall positive charge, and it's positive 1, so that we need to get rid of just 1 electron. Erase it. So we're left with 3 protons, 2 electrons, which gives us an overall charge of positive 1. Perfect. Fluorine has 9 protons, so 9 electrons. But this time we have a negative charge, which means we need 1 extra electron, because positive cancels positive. We're going to go through and we're going to count. And we need an overall negative charge, so add 1 more electron. Then they match. Oops. Way over. And then nitrogen, we'll do real quick. 1, 2, 3, 4, 5, 6, 7. And then normally we'd have 7 electrons, but we have an overall charge of negative 3. So to cancel out all these, we need 1, 2, 3 extra electrons. So we'd have 7 protons, and that's 40. We don't need that. 10 electrons. So if you still have questions about this, check out the other videos to get a brief explanation of how to count these, or come into class and I'll show you in person.